Courtesy of Baker Distributing, I have some sequencers to show off. So here we go. This is a fan sequencer. It's pretty simple, really. Your control voltage would plug in here and here, usually 24 volts, and then just like this box says, that the fan sequencer will cause a delay on the fan to come on for anywhere from 1 second to 20 seconds, and then a delay for it to go off for 40 seconds to 110 seconds. Now let's look at this heat sequencer, which is very similar to the fan sequencer. Everything is the same about it except for, of course, the on time and off times. The heat sequencer, once it gets a call for heat, it delays the heat for 30 to 90 seconds. And then after the heat call, it continues for another 1 to 30 seconds. This is your control voltage bimetal heaters right here, and right here is where your load and line connects. Now right here we have, now this one is a fan sequencer similar to this one. Look at this. See, this is a single pole, single throw, as this one is a double pole, single throw fan sequencer. Now let's look at this heat sequencer. It's also a double pole, single throw, as this fan sequencer is a double pole, single throw. These two sequencers are very similar in that the control voltage connects to these bimetal heaters, and then your line voltage, see, remember double pole, so you can connect 2 poles to this one, and your line voltage could connect here and here, and then your load would connect here and here. Here is a fan and heat sequencer. All it really is 2 sequencers tied together. And what you have here, see, like here, right here is M1 and there's M2. So this is where your fan line voltage would connect. And here on the bottom, of course, this is where your control voltage would connect. And this is where the voltage going to your heat strips would connect. Now, to show you sort of an example of how a sequencer works, I've taken this fan sequencer, for example. I have my multimeter set up on the continuity range, and I have the leads attached to the line and load terminals where you would normally connect your fan voltage, and I have a transformer with a secondary voltage of 24 volts set up so that when I connect this alligator clamp here to the bimetal heater, that it'll start to heat up, and within say in about 20 seconds it'll close this position so that the fan would come on. Here, let's try it. Here goes. And I've applied 24 volts to the bimetal heater. Now let's watch. There it goes. So see, it took about 20 seconds for that bimetal heater to energize. Now let's disengage the 24 volts. And of course, according to this, it takes about 40 to 110 seconds to disengage or to open this switch, this bimetal switch in here. There it goes, and now it's off. Now, if I decide to go ahead and send current, the 24 volts, to this bimetal heater again, which I'll do again, it shouldn't take too long for it to heat up and close the position. There it goes. See, it didn't take 20 seconds that time because I had already heated up the bimetal heater in there. Now when I detach this again, it'll probably take another, say, almost a minute or so to open this switch. And there you have it. The switch is now open, meaning that the fan would stop running if this were connected to an air conditioning system as a fan sequencer. And that's that.